Thank you, and good afternoon, everyone. Thank you for coming to talk. I'd actually like to thank the organizers for inviting me. I've actually have not that much connection to the system dynamics community. I guess my home community is in econophysics, and that's why part of my talk is on critical transitions in markets. As you can see, I am from the Nanyang Technological University in Singapore. And besides, I'm also a part of the Complexity Institute, which draws faculty members from the different schools, and I'm from the School of Physical and Mathematical Sciences, which has the three disciplines, physics, chemistry, and mathematics in there. So let me move on and tell you a little bit about the outline of my talk. So first of all, I'd like to explain the motivation behind this series of slides that make up my talk. I am interested in critical transitions of all sorts in complex systems, and obviously socioeconomic systems are complex systems. And after giving the motivation for trying to look at these kind of things, I go through a series of examples. We'll start off with the US housing market, where we try to detect early warning indicators, signals of the housing crisis in the US that has since gone by. And then after that, I look into the Singapore housing market, where we actually are currently experiencing a housing bubble, and to see whether the early warning indicators that were described by Martin this morning will actually continue to hold true, and actually we try to test them to, I guess, far greater extent than most people are willing to do so. Then finally, I'm going to, not finally, but the next test case I'm going to talk about is actually going into the murky realm of social-political opinion, where we try to monitor the kind of things that are being said on online discussion forums. And when we detected actually an episode of critical slowing down in this kind of system, and then we eventually, when we try to look around for possible causes, we realized that they can be explained by the Singapore 2011 general election. And then if I've managed to get that far, then I will talk about another line of work that I'm doing, then that is to do quantitative forecasting based on a statistical model of fusion and fission dynamics. So let me get started going through the motivation for this talk. First, to understand why is it important to try to understand or to actually detect critical transitions in socioeconomic systems. So for the regime shifts in markets, so this is probably something that is fresh on people's mind. The Chinese market crashed in June and July this year. In fact, the market, this is probably one of the largest market crash that we have seen in recent history. Most of the mature markets will not actually suffer a scale of collapse that is this size, but the Chinese stock market is an emerging market, and I guess the investors are not quite yet accustomed to how to handle themselves in crisis. So they all they all heard it, and this then led to a crash of this kind of scale. And here's a more detailed exposition on the actual crash itself. You can see that the Chinese stock market lost 20% of its value in 2 days, and then it rallied, partly due to intervention from the Chinese government. The Chinese central government actually pumped in a lot of money into the stock market, and then it rose about 15%, and it dropped another 12%, and it lost another 15% in 24 hours, after which the central government decided that they don't want to do anything anymore. Okay, so, and of course then you can see pictures of dejection like this investor, or resignation by this investor. So obviously we don't like market crashes. We want to be able to avoid them if at all possible. If not possible, then maybe we can lessen its impact. But for social regime shifts, the situation is far more pronounced. This is a picture of the Arab Spring in Tunisia. And of course, a lot of other similar uprisings occurred in the Middle East and the Arab world. When we first learned of Martin's work through his 2009 review, actually we learned it later, of his 2009 review, we wanted to test whether those kind of early warning signatures can be seen in social systems like this. So our test case was Egypt, but we could not get any data. We don't have Twitter data sources. So we made use of Google Trends. We actually looked at the autocorrelation in the Google Trends, basically what people search, and we use the Arabic term for revolution. And we found that, well, I mean, there is actually some signal because we had to use 1 year window to do average, to compute the rate shift in the power spectrum. President Mubarak had about 1 day to get out of the country before the uprising erupted, and obviously that is too short for him. So we wanted to see whether we could do more, do better. This is a similar uprising in Ukraine, which disposed of the president, and of course gotten Ukraine into a lot of mess since then. So these two were actual regime shifts, social regime shift, political regime shifts. And these two, the following two actually did not resulted in any change of the political system. The first one is the Sunflower Movement in Taiwan. They actually occupied the parliamentary building and prevented the government from actually meeting there to sign an agreement with China on some kind of service trade agreement. This is the Occupy Central Movement in Hong Kong, where they demanded that they be given the right to decide on the candidate that they eventually should vote for when Hong Kong gets its election. I think in 2017, of course, they're not happy that the Beijing government says that they want to screen the candidates that will go up for the elections. Okay, so obviously these systems are all social systems. There are many variables involved. Many different people measure different variables because of where they come from. So how do we detect critical slowing down in this kind of situation? So this is, I don't need to review this anymore because Martin did a good job reviewing these two. So I'll just quickly go by. So these are the kind of indicators, these are the kind of indicators that we can try to look for. Signs of critical slowing down, where we try to see whether the recovery rate is decreasing, whether the autocorrelation is increasing, whether there is spectral reddening in the power spectrum. We can also monitor the dominant eigenvalue to see whether it is about to cross zero, or we can measure fission information in the fluctuations, or we can look for all other kinds of indicators. And I will show you one of the experiments that Martin has also showed, where actually they have a container containing cyanobacteria that is being illuminated by bright light. If the light gets too bright, then the whole population dies off, and then they perturb it periodically to see that it recovers, but the recovery rate becomes slower and slower, which is shown. Let me see. Yeah, which Martin has shown here, and actually there are similar experiments later on, but let me just skip this so that I can have more time to talk about the kind of study that we have done on our own. So the first test case was on the U.S. housing market. The critical slowing down signatures can be seen very clearly in the climate data, in fisheries data, and even in epileptic seizures data. But for something that is not quite a physical system, but a socioeconomic system, will things like this work? So we first tested it out on the U.S. housing market, and this is work done by my PhD student James, and you will see him again later on. And the first thing we did was to try to look for signs of rate shift in the power spectrum. The data that we used were from two sources. The U.S. Census Bureau. This would be the monthly housing permits that were issued for the various metropolitan statistical areas. And then we also downloaded monthly data from Zillow.com. This is from about 3,000 U.S. cities, about around the same period of time, but this covers homes sold, median sales price, and the percentage of home that is sold for profit. And when we computed the power spectrum, so what I need to explain a little bit, so this axis shows you the various U.S. cities, and this is, of course, time. The color indicates whether there is a spectral reddening. Actually, this was an older graph, and we should have made the spectral reddening red instead of blue. But what you can see here is that the blue color indicates more significant spectral reddening compared to red. And what we then did was to set some threshold and counted the number of cities that exceeded that threshold for critical slowing down. And we find that there's one peak here, one very strong peak here, and then a series of almost equally strong peaks before the end of the subprime crisis. So this, in fact, we can see a little telltale sign of the Asian financial crisis, but this is in the US housing market, not Asia financial, not in the Asian market. And then, of course, we can see some telltale signs of the technology bubble as well, because this is understandable. When people get burned in the stock market, where do they take their money to? They will take their money to somewhere they think is safer. In those days, the US housing market was probably considered very safe. And of course, this was the subprime crisis of 2007. This is the Lehman Brothers crisis of 2008. So what on earth is this very big, very strong peak here in around 2003, 2004? So we did some investigative work on our side, and we discovered that this was actually around the time when the proportion of subprime loans, because normally the US banks will also give out loans to people with good reputation, who has a track record of repaying their loans on time, but they also give out loans to people with poorer credit history. You can see that the proportion rose from somewhere below, I guess, 3% to more than 15% in a very short period of time. So this is around 2004. So this is actually, so we think that this is actually the early warning signature for the subprime loans transition. Okay, and then we started looking at other kinds of data, other indicators. So this is correlation, and again the indication is there. We looked at, we didn't look at we also look at the variance, but the signal is not quite as strong. But we look at, we look for the slowing down signatures, sorry, too fast. Yeah. We also look at slowing down signatures in other variables other than housing permits, and we see them in the homes sold, we see them in the percentage of homes sold for profit. So they are all there in the data. And of course, after we see these things, we try to understand whether there is some kind of a spatial-temporal pattern in the distribution. So what you should see here is there was a big swath of blue earlier on that corresponded to the critical slowing down. So the animated GIF will recycle. So this is year 2000. Red is, again, the color scheme is opposite. So you can see what you should be looking for will be a big swath of blue around the period 2003, 2004. So so you see this a big swath of blue that spread across the US. Around that time, that was the early warnings, the critical slowing down signature for the US housing market. But otherwise, you can see that there's no apparent, there's no proximity effect for which of the cities are affected, and we believe this has to do with the network of banks in the US and how they are actually distributed across the US. And then we further looked at the transition cross sections. So what we are showing here again is this is the cities, the US cities. This is the time, but we are now ranking the cities in a different way. We are ranking those, we are showing those white part will be cities that first experience critical slowing down, and then these are cities that experience critical slowing down slower and slower, later and later. And you can see that these four variables, they don't actually have the same behavior. You can see that the percentage of homes sold for profit kind of changes linearly. And so is this is almost continuously, and there are step-like functions in these kind of things. Now, in statistical physics, we talk, especially if for those who are familiar with the renormalization group theory, you would have learned about the existence of relevant variables and irrelevant variables. So what we expect is that only the relevant variables would show critical slowing down, and variables like this are kind of irrelevant. So only those that show step-like structures should be considered relevant, and therefore they should be the one that goes into constructing the order parameters for the system. So that's for the housing market. We published this at the beginning of last year, and then we move on to look at the Singapore housing market. Now, what was unsatisfactory about the US housing market data was that it was a series of monthly data. When we tried to compute the power spectrum, we were constrained to using a 2-year time window because otherwise there would not be enough data points to compute the Fourier spectrum. So we wanted to see whether we could get transaction level data. And fortunately, the Singapore housing market, we could get transaction level data. And from the transaction level data, actually, we discovered that we could see, actually, in very clear terms, what the housing bubble looks like. So this is, let me see what else I have to say here. So this is the home price distribution for a particular housing type in Singapore. It's a private housing, but it is high-rise, not the kind of suburban homes that Americans are used to. And you can see that this is on a semi-log plot, more or less a straight line. So this home price distribution is distributed as an exponential, but there is this positive deviation down here. Now, in the words of Didier Sonnet, such deviations are called dragon kings. So they are phenomenon that are more statistically more likely than you expect them to be. And if you do a dragon king test, various dragon king tests that Didier Sonnet proposed, these things will come out to be statistically significant. And I show you also on the inset the same plot, the same data plotted on log scale, and you can see that it is not quite a straight line, so there is no power law in the condominium housing market. But there are power laws in a different housing market. So after seeing the housing bubble, we wanted to, first of all, we understand that this was due to the property market being liberalized in 2006, but we wanted to see whether we could see it, the early warning signatures. So this is a plot of the transaction volumes, monthly transaction volumes for the 3 different housing types. So this is public housing. Condominium is the one that I've just shown. Landed properties are the kind of suburban homes that Americans are used to. And you can see that their transaction volumes are rather different, but more or less at different levels. And what I should explain to you is that in Singapore, 82% of homes are public housing. Only 12% are private condominium and 6% are landed. You can see that this is about 6% is reasonable. But what is a bit interesting is that 12% of the home stock in Singapore generated a sales that exceeds 80% of the home stock during this particular year, and this is officially recognized as the start of the housing bubble in Singapore. But do we see early warning signatures? So we went ahead to compute the, okay, so let me just skip this for the time being, because it doesn't add to the story. So the early warning signatures, this is the, again, this is the spectral radiating signature. Again, we can see that there is the power is more or less evenly spaced out during these quiet years from 2000 to 2005. And then between 2005 to 2010, the power is concentrated at low frequencies. So this is, of course, probably related to the bubble. But we also see actually a separate spectral radiating episode from around 1997 to year 2000. So this is probably related to the Asian financial crisis. So whenever there is a housing market crisis, we have some confidence that we are actually looking at the early warnings indicators. So, but there is another kind of early warning indicator that we can look at, that we can check, besides the autocorrelation, which I will skip, because it tells the same story, and that is the story of slow recovery. So what happens is that, okay, so what happens is that I am trying to give you a cartoon picture of what happens when a property is about to go on the market. So obviously, just before the property hits the market, there is intense advertisement in Singapore. And then after that, there will be the property will be launched. which means that you can the public can now go and inquire and actually reserve units. And then you will generate a peak of sales that that rises to a peak and then decays more or less exponentially. And then maybe cooling measures will be announced, but they may not take effect on that same day, and therefore there will be a peak of activities where people, the speculators will try to sell off whatever they have, and then maybe another cooling measure announced, a second peak, and then finally, when the project is completed and the fire department issues a temporary occupation permit, now people can actually move in. There might be a next series of, a next peak of transaction activity. And so this is what we kind of should expect from the data. So here I show you 6 such six such plots. The first 2 are good ones, so you can see that these 2, the monthly transaction can be fitted very well by exponential decays. These are decent ones, so you can see that the fit to exponential decay is okay, but maybe there are some noises here that is hard to understand. It may be caused by the cooling measures, but we have to put those in. And this blue line here indicates that the project was completed at this time and received its temporary occupation permit. And then this is another one that is fitted okay. These 2 are considered bad. Okay, but the earlier one is not so bad, but this is actually it's not too bad either. And then there are unusual ones like this, where you try to fit to an exponential, and you see that, well, it doesn't fit very well at all. And here's another one where the fit is not too bad, actually. And so what we have here is that by thinking about property launches as perturbations to the housing market, we have therefore identified in situ probes of proximity to regime shifts and response to interventions. So after I've obtained this series of plot, I told my PhD student that he should go and try to get more data over the series of years, and this is the graph that we get, and we don't know how to make sense of this, so I asked him to put down all the important dates. So these are the various crisis years, these are the interventions, and I guess the story is still very confusing at this point, but we will go back and we'll study this result more carefully. But I think I need to move on in the remaining time to the social story. So this is a story about the 2011 general election. So like the housing market, the social media is also self-exciting. So if someone goes on an online forum and posts a thread, he actually excites the opinion of others, and they will start to post responses in response to the original comment. And then over time, of course, these comments will die away. And if you are deep in one of the socio-political opinion wells, then that decay should be very rapid. But as the energy landscape moves towards a bifurcation, you see that the decay becomes slower and slower until the system goes over to the other side. So this is what we expected to find. So we started to look for data. We could find 4 popular Singapore online forums, and then we crawl them using crawlers written in Scrappy, and we measure the relaxation rate. So these are the exponential fits. They are not too bad. And then we look at the quality of the fit, and most of the fits are actually quite decent as well. So only a small number produces very poor fits. Those we do not actually plot. And these dots here are all the relaxation rates of all the threads on this particular online forum. And of course, we can't see anything, just like for the housing market. So we average over 1-year windows to obtain the black curve. And of course, the scale is too small to see anything. So we went and zoomed in, and then you see something like this. So here, the relaxation rate is slow. Here, the relaxation rate is fast. But what is the meaning? So it turns out that in order to understand the meaning, we have to separate those data into political threats as well as non-political threats. So these are the threats, the relaxation rates, after we have separated them into political threats versus non-political threats. And what is interesting is that you see that So the red, blue is political threat and red is non-political. You see that there's an episode of critical slowing down here, here, and here. And this actually, the timing corresponds to the 2011 general election. So I will skip some of these to just talk about the very last slide. So this very slow. So this is how actually we identify the political keywords by plotting a planar maximum filtered graph. And I'll skip this as well and just talk about the earthquake study that is based on a soup of group models that was introduced by Neil Johnson in his Nature paper in 2009 to use to describe terrorist attacks. And while we tried to develop a mean field theory for this, let's very quickly finish going through this. Mean field theory for this, and then we fit this we extracted early warning indicators that were implied by the model, and we find that we could successfully predict the 1999 magnitude 7.3 GT earthquake. And I don't have time to show the movies, but so this is the paper that was published. And then we also tried to use this to do similar predictions on the Singapore Stock Exchange. The results, we have limited success on that, but it's still considered successful. But when we tried it on the New York Stock Exchange, we failed miserably, so we're trying to understand why we failed. So I guess I just have to go all the way to the conclusions and say that. So that we're trying to say that actually we have developed confidence along the way that we can actually make forecasts, quantitative forecasts of critical events like this, not just in understanding the nature, but also in predicting when is the most likely date that the critical transition is likely to happen. So thank you.